All right, welcome back, viewers. So in this video, we'll be looking at hyperbola with shifted center and not vertex shifted center. So what happened is that the formulas will change a bit. Here you can see we've introduced H and K, and the center now is HK. So if you are dealing with the horizontal vertex, the horizontal hyperbola, the transverse axis in this case is going to be parallel to the x-axis. And in the case of vertical hyperbola, the transverse axis will be parallel to the y-axis. And also another notable change has to do with the asymptotes here as well. The slope still remains as b over a for the horizontal and a over b for the vertical. But now you have a shift, both the horizontal shift and the vertical shift. Okay. And also here, you see that here in terms of vertex. Now, what happened here? You have plus H. So let me just, before it used to be what? It used to be plus A0, right? And here used to be 0 plus minus A, right? So now with HK, you just need to add H to the x-axis, which will give you A plus H, and add K to 0, which will give you this one. So the same apply here. And also for the foci, here used to be plus minus C0 when the center is at 0. Then you just need to add H and what? And K. So that also apply here. Here used to be 0 plus minus C. That is when you are dealing with a vertical hyperbola, right? Now, if you had H here, this will be H, then plus minus C plus H. So that is how you have this formula. So it's just an addition of the HK, so just to bring in the center, right? Now, let's go to this example 4. What does it say? It says, find the center, the vertex, the foci asymptotes of each equation and graph. So let's start with the first one, A. Now, this is 16x squared minus 9y squared minus 32x minus. So this is more like in general form. So we have to write it in standard form. And how can we do that? Just by completing the square. So let's keep the x's together. We have this minus 32x, then minus 9y, and this would be minus 54y. It's equals to minus 79. Before we apply completing the square, we always want the coefficient of x to be equals to 1. So this is going to be 2x. If you take 9 here, this is going to be y squared plus, it's going to be plus 6y, and this is minus 9. So here we will do completing the square inside. So this is going to be x squared minus 2x plus 1 minus 1. Yeah, because half of the coefficient of x is what? Is 1. Then you square it, you add it, you also remove it here. Minus 9. This is y squared plus what? 6y plus 9 minus 9. So this we can write as inside these 3 terms here is nothing but x minus 1 squared, but there is a minus 1. And here also, these 3 terms is nothing but y plus 3 all squared, but there is a minus 9. So here we have to be careful because of these numbers behind them. So we have to be watchful about this. So if you see now this, if we expand, this is going to be 16x minus 1 squared. Here, because of this minus, this is going to be minus 16, right? Minus 9 into this. Minus, this is going to be plus 81. So now we can rearrange. So this is this minus 9y plus 3 squared is equals to minus 79 plus 16 minus what? Minus 81. Now this will be equals to 16 x minus 1 squared minus 9y plus 3 squared. And this will give us minus 144. So we divide both sides now by minus 144. This will just become negative. This will become positive. So you have 9y plus 3 squared over 144 minus what? 16 over 144. It's equals to 1. All right. So now what can we do here? We can divide. We can divide both sides by 9. This is just going to be, so you divide the numerator and the denominator by 9. This is going to be y plus 3 squared over 144 divided by 9. And this is going to be 16 minus, this is x minus 1 squared. And this is going to be 9 equals to 1. All right. So now if you compare with this, you see that the positive is associated with what? With y. So this means you are dealing with a vertical hyperbola. We're dealing with a vertical hyperbola. Okay. Now, dealing with a vertical hyperbola, what can we do with it? We need to get our center because you compare. So if you compare with what? Compare with y minus k squared over what? Over a squared, right? Minus x minus h squared over b squared is equals to 1. It simply means that a is equals to what? You see that a squared is equals to 16. Or let's even start with hk. So, okay, I think, can I do it? So we can see that hk is nothing but what? H is going to be 1. And what is k? K is minus 3. Then a is 4. And b is what? B is 3. A is 4, b is equals to 3. Then c squared, or we can say c is a squared plus b squared, which is just going to be 16 plus 9. So this is just going to be 5. All right. Now this stops. All right. So let's go now and just let's try to sketch this based on what we have so far. Okay, I'll try to sketch this here. Now, to sketch, what is important is what, in this case, is the center, right? That's the first thing that is important, the center. Now, what is our center? We know that the center is 1 under minus 3. So center is 1, so it means x is 1. So it means we're in the 4th quadrant. So let's call this 1. and this one minus 3. So this is our center. Now, what type do we know? We know that we are dealing with what? We are dealing with a vertical hyperbola, right? Now, since it's a vertical hyperbola, we know that what? A vertical hyperbola, it means our vertices is going to be on what? Remember, our vertices is going to be vertical. Our transverse axis is going to be vertical. So it means if this is the center, we have to go a vertical. We have to go a vertical of, remember, what is our A? Our A is 4 and B is 3, right? Let's see. Yes, A is 4, B is 3. So it means from the center, we have to go vertical a distance of 4. Remember, this is already minus 3. If this is minus 3, when you go up 3, you'll be at 0. So it means you're going to be somewhere here. So this is going to be one of our vertex. And what is this point? As you can see, the h remains the same. The x value remains the same. But the y value is now what? Is now 1, right? Okay. Now, in the same way, we will have to come down. How many units? 4 units. So if I come down 4 units somewhere here, this is going to be this point here. Let's call it our V2. So for the V2, you see that we will still have minus 3, right? No, sorry. No, this is not true. Okay, I think for the V1, you see for the V1 here, look, the value of x is still 1. So it's going to be 1 and 1. Yes, because the x value is what? Is 1. The y value, this is minus 3. If you add 4 to minus 3, the y value will be 1. So the first vertex is 1 and 1. The second vertex is, look, the x value is still 1. But the y value, here we have minus 3. If you come down a distance of 4, it's going to be minus 7. So this is minus 7. So this is our vertices, right? So this is our 2 vertices. So let's write this as minus 7. Okay. Then now, remember, don't forget that this is our center. So we have to now go horizontal, because this is our conjugate axis will now be horizontal. So we have to go a distance of what? This is B. B is 4. So from here, I have to go a distance of 4 to the right and a distance of 4 to the left. Yes. So how do we go a distance of 4? No, sorry, a distance of 3. So if this is 1 here, then somewhere here, so somewhere here, and what will be this point? This point is going to be the x value. If you add 3, so it's just going to be 4 and what? Minus 3. And also you have to go a distance here to the right. So this is going to be minus 2 and what? And minus 3. So these are the endpoints. Okay. All right. So now what do we need to do? Just like we did before, you can just connect. You connect your what? Your vertices. And so let me just do something. So let's draw this. Let me bring this a little bit closer here. So this is okay. So this is what we're going to use to draw our what? Our asymptote. So now this, you can see this line here, it's our conjugate axis. So this is actually our conjugate axis, this one. And this one here is the transverse axis. So the length of the transverse axis is actually this one here, this line that connects the center here. Okay. All right. Now, what can we do? You can just draw your what? We can just have a sketch of the asymptote. And how do we draw the asymptote? The asymptote should come from where? These corners, and must pass through the what? Must pass through. In this case, remember, the center is not the origin. So your target should be how it should pass through this center. So it's just going to be something, but it should pass through the center. So here, I think, and try to connect the corners. So I'm not drawing this to scale, so it doesn't really look nice. And let's see. Okay. It's just going to be something like this. Okay, as much as possible, try to draw it through the corners, and here also. And just not really straight, but this is somehow the asymptote. And then what next? You draw through the vertex. Remember, these are the vertex V1, so just draw something here through the vertex and close to your asymptote. And here also, this is the vertex, and draw close to the asymptote. So you will have a rough sketch that looks like this one here. So you can remove this. Now, there is something we've not shown on this graph, and that is our what? Our foci, our two focal point. Now, how do you find these two focal points? You just need to calculate your what? Your C, right? We need to find what is that C. So what is C? We already have C. Look at C. C is what? It's 5. So C, it's 5. So it means you have to calculate a distance of what? Of 5. From where? From the center. Yes? So now look at it. This is the center here. This is our center. So, and don't forget that the focus is going to be also on the transverse axis. So you have to go a distance of 5 upward here. So remember, here is 1 and 1. So if this is -3, if you go up here, the y value remains, the x value remains the same, which is still 1. Yes, sir? It's still 1, but going a distance of what? Of 5. Remember, this is -3. If you come here, this is going to be 3. By the time you reach here, you are what? 1. So here is going to be 2. So this point is 2. This is our first focus. So you can put a point here. This is going to be our first focus. Call it F1. And what is the point? It is going to be 1 and what? 1 and 2. Then the same way you go down here, you're going to have the second, you see the x values remain fixed, so it's still going to be 1. So F2 is going to be 1. But remember, from the center, you are coming down a distance of what? Of 5, because C is 5. So that will go to bring us to -8. So this point is actually -8. This is -8. And then it's fine. So this is a rough sketch of how the graph should look like. And you can get every other thing you want. Now, the important thing here is your asymptote is not passing through the origin. It's passing through the what? The center. And so draw it in such a way that it passes through the center and it goes close to your curve either way. So it doesn't have to pass through the origin. As you can see here, this is our focus. And what is the center? The center, remember, our center is 1 and what's minus 3, right? All right, so done. Now we can find every other thing you want to find using the formula. So we can also use the formula to find. So let's just write down these parameters here just by the side. So the center is what is HK. And we know that that is 1 and what's minus 3. Now the vertices by formula is what? Is H is fixed. Then you have, it's going to be minus A plus K, right? And what's H and A plus K. And that is, what is H? H is already fixed, so you're going to have 1 and what? And 1. And then 1 and what? Minus 7. So these are the two vertices, V1, V2. Then you can find your foci, which is just going to be, H is still fixed, so you'll have minus C plus K, and what's H, C plus K. So H is still fixed, so it's still going to be 1. And then, as you can see, F is what? It's going to be 1, 2, and 1, and what's minus 8. You can also find the endpoint of the conjugate. These are the endpoint of the conjugate, these 2 points here. This is 4 minus 3, and this is minus 2 and minus 3. So you can add it. All right, so, okay, and one important thing that we should calculate is the what? The asymptote. So let's find the asymptotes here, I think. Let's find the asymptotes. The asymptote is still y is equals to what? Now it's going to be y minus k. It's equals to what? Plus minus a over b, x minus h. So we know what is k. So it is y plus 3, right? Because k is minus 3, which is the center. And this is plus minus a is 4, b is 3, then x minus h, which is 1. So this will give us these two asymptote, vertical asymptote. So you can split each of them. So it means y plus 3, it's equals to y over this. You can leave it like this, or you can write it in a more. So minus 4 over 3. So these are the two lines. All right. So any other one? Let's see. Are we done with this one? Okay, so we have question B. Let's deal with that. All right, so we take the second question, so which is B, and it's giving us x squared minus y squared minus 6x plus what's plus 8y minus 3 is equals to 0. So this also, we just put the x's together, and this is equals to 3. So this here, it's already fine. So we can rewrite these as x squared minus what's 6x plus 9 minus 9, right? Then here, let's put a minus here. Okay, let's rearrange this first before we start. This is x squared minus 6x minus, this we can write this as y. So here becomes minus 8y. equals to 3. So this is x squared minus 6x plus 9 minus 9 minus, here we have to do it inside. So this is going to be y squared minus 8y plus the half of the coefficient. So this is going to be 16 minus 16 is equals to 3. So this now we can write as just x minus 3 squared. Then minus inside here. Okay, let me go one more step. This is minus 9 minus this one, this 3 terms here is going to be y minus 4 whole square, but there is a minus 16. So this is now x minus 3 squared minus 9 minus this. If you take this minus inside, this is y minus 4 squared. But because of this minus, here becomes plus 16 equals to 3. Then this is x minus 3 squared minus y minus 4 squared. And then you'll have 3 plus 9 minus what? Minus 16. So what do we have here? This is going to be x minus 3 squared minus y minus 4 squared. It's equals to what? So here you will have 12. So this is minus 4. Minus 4, correct? Yeah. So now what next do we get? We can divide both sides by minus 4. So this is going to be y minus 4 squared minus x minus 3 squared, because we are dividing by minus 4. So let me write it clearly. If you divide by minus 4, this divided by minus 4, you have y minus 4 squared over 4. And this would be minus x minus 3 squared over 4. This is equals to 1. Okay. All right. So here, okay. So if you look at this now, we can write this as what? It means that this is simply going to be a vertical hyperbola. So what is the center? Okay. So yeah. A is 2, B is 2. Then we need to talk about the what? The center, right? So what is the center here? The center is going to be HK. So the center is 3 and 4. All right, so what is C? We can find C also. C is just going to be the square root. The square root of A squared plus B squared, which is just going to be square root of 4 plus 4. which is the square root of 8. Yeah, which we can write as 2 root of 2. So let's try to get these informations and try to sketch this graph. So the most important thing first is the center. And what is the center? We saw that the center is just what the center is. You write the center here. HK is, H is 3 and K is what? Is 4. So it means we're in the first quadrant. So let's say 3 and 4 happens to be here. This is 3. And let's take this to be 4. So this is our center. Now, what type are we dealing with? We are dealing with a vertical hyperbola. So since the A is associated, the positive is associated with Y. So I remember A is 2, right? So it means from the center, you just need to go a distance of what? 2 up. So 2 up should be somewhere here. So let's just, this is it. So this will be our vertex. Again. So this will be 3. And if you go a distance of 2 up from 4, this is just going to be 6. And then you go a distance of the same down. This will be our other vertex here. And what will be this point? This point you can see is still going to be 3. But from 4, if you come 2 down, it's just going to be 2 down. So this is our V1 and V2. Then you think of going sideways. Think of going sideways for the conjugate. The conjugate, if this is 3, right, remember our B is also 2. So you will have somewhere here 3 and 5. Sorry, this is going to be, you go 2 to the right. So this will be 5 and 4. So this is 5 and 4. And then you come to the left again here. Here, this is going to be 1 and what? And 4. So that is it. So we're just going to have something like this. Okay. And then we will have our center here. So let's have this to be our verticals through the center. And then also here through the center. Keep going, keep going. And then we will have, remember this is our vertex here. So it's just going to cut the vertex like this, close to the asymptotes. And also here, something like this, close to our asymptotes. So these are our lines of asymptotes, these ones. Okay. And so that will be the graph, how it looks. And don't forget we have our origin here. All right, so this is how the graph should look. But one thing again, we have not is the focus. So what is our focus? Remember, our focus will be on the transverse axis. So it's going to be on the x-axis now, the y-axis, I mean, since we're dealing with vertical. And since our C is what is this? This is our C here, which is 2 root 2, which is yeah, squared. So this is root of 8. Right. Okay. So our focus will be somewhere here, also on this line. This is our F1, and maybe somewhere here. But what will be, you can see this is fixed. So our X is fixed. So this is going to remain as 3, right? As 3. Okay. Then you can see what will be the Y value. Remember, the Y value here is 4, right? So you just need to add the C. So it's going to be 4 plus 2 root 2 here. Yes. And also here is going to be somewhere here, which is still going to be 3. But now you will have, it's going to be minus, right? Because you have minus 2 root 2 plus 4. Okay. All right. So we can just try to write down these things directly here. So let's try to write them here. What is the center first? The center is HK, which is 3 and 4. Now, vertices is going to be H minus A plus K, and what? H, A plus K. Now, and you can see that we got that here because our H is what? Our H is 3, right? So 3 is always fixed. So that's why we have 3, 2, and what's 3, 6. Because if you use the formula, what is A? Remember, A is minus 2. So you have minus 2 plus K, which is 4. So it will give you this one. Here, if you use that there, A is 2, 2 plus 4 will give you 6. So these are the vertices. Then now the foci, which is H is fixed, you have minus C plus K, and also H, and then C plus K. So what is H? H is fixed as 3, so here will be 3, then minus 2 root 2 plus what? Plus 4. Or you have 3, then 2 root 2 plus 4. So this is why we have this 2 to be our focus. So you can call this one F1, you can call this to be F2. All right. Then you can get other parameters that you want. So, but let's just get one more. Let's just get the asymptotes, the lines of the asymptotes. It's going to be y minus k is still going to be a over b plus minus, then x minus h. So this will be y minus k, which is 4. It's equals to plus minus. The slope is going to be 1 because everything is 2 over 2. Then x minus h, which is 3. So you'll have 4y minus 4 is equals to plus minus x minus 3. So this will give you 2 asymptotes. So the domain is going to be, so let's see what will be the domain here. Just add it. Is our domain. Our domain is still going to be minus infinity to infinity, but the range will be from minus infinity to the y value. What is the y value here? Is the y value here is 2, right? Union 6 to infinity. All right, so let's go to example form. Example 5 says, find the standard form of the equation of a hyperbola having this. Now, if you look here, look at the vertices. See, this one is fixed. It means the h is not changing, right? The x-axis is not changing, so it means the y value is changing. So also you can see here the same thing. The x-axis remain fixed. So what does that tell us? That tells us that we're dealing with a vertical hyperbola. So let's write it. You have that the vertices are what? Minus 1, 1. And okay, let's say minus 1, 5. And this tells us that you're dealing with vertical hyperbola. So, and how do you find the vertical hyperbola? This is simply given by the formula. H is fixed. So you have minus a plus k, and what? H, a plus k. Right? So these are the formulas. So here you can, it's clear that H is equals to what? H is equals to minus 1. It's clear. So if H is equals to minus 1, you can use any of the equation to find. Here you can see that a plus k is either 5 or minus a plus k is what? Is 1. Now, by the time you add this, you should have 2k is equals to 6, right? And this tells us that k is equals to 3. Now, once you have k is equals to 3, you can substitute k. You can call this 1, this 2. You substitute k in what's in 1. You will have a, it's equals to 5 minus k. So a is going to be 5 minus 3. And I think a is equals to 2. Right? Now, if you have a is equals to, what is k here? Let's see. What do we have here? A plus k is equals to 5. What are the vertices? Minus 1, minus 1. Okay, so this is minus 1 here. So this is minus 1. So this is going to be 4. And that means k is 2. If k is 2, then a is 3. All right. Now a is 3. What else can we find? We need b, right? But we cannot get b but we can use the focus now. We know we're given that the foci is minus 1, minus 3, and what's minus 1 and 7. And this simply means by formula, this is h minus c plus k, and this is what? H c plus k. So here also we can have two equations to find what is k. Yeah, it means that c plus k is equals to 7, and what's minus c plus k is equals to minus 3. Yeah, but I think we already have what is k, so we don't even need two equations. We can use only one. So what is k? K is already 2, so we have c plus 2 is equals to 7. So c is equals to 5. Now we know that c squared is what? A squared plus b squared. And this implies that b squared is equals to what? C squared minus what? Minus a squared. Right? Yeah, so we have, yes, so what is b squared? What will be c squared? This will be 25 minus 9. So b squared is going to be 16. So now I think we have everything we want to finalize this problem. So therefore, remember, we're dealing with what? We're dealing with a vertical hyperbola, right? Now, since we're dealing with a vertical hyperbola, what does that mean? Vertical hyperbola, well, let's write the vertical hyperbola. It means the a has to be associated with what? With y. So this is going to be something like this. And h squared over b squared is equals to 1. So we're going to have y minus k, which is 2 over a squared. A squared is 9, right? So a is 9 minus x minus h. We have h here. I think h is minus what? Minus 1. Clearly from the vertex, h is minus 1. So it's going to be minus minus, it's going to plus 1 over b squared, which is 16. And this is equals to 1. So this is the equation in standard form. All right, so that is the end for this video. The next video will be solving some few old exams. So thank you for watching.